put into this sigma x plus sigma y. Okay, this one can be written like this. The three equations in green colors are the basis of the building up the Moore circles. Okay, so right now we have two methods. One is either go to the fundamental calculations, or we base upon the green one to build up the Moore circles. And most of the time, using Moore circles are more convenient and easier. So we pick up the two equations and start with that one for the Moore circle. So let me define the average is, this is called the define, okay? Sigma x plus sigma y. So therefore from here the sigma x prime minus average will be equal to sigma x minus sigma y. Because those are the old stuff, so I perceive this one will be quicker. And then tau x prime y prime will be equal to minus 2x minus sigma y sine 2 theta plus tau x y cosine 2 theta. So with the two equations, if you we play around a little bit more, sigma x prime minus sigma average, we simply take the square of the each terms and we take the summations. This one will be equal to r squared, and where the r is equal to this one serving as the basis of building up the Moore circles. You can see this one is the circle, the equations of circle, and with center sigma at sigma average and radius equal to r. Right? So that is the basis of the Moore circles. So from here you can see basically we can quickly build up the Moore circle like this. The first one we calculate, this is a circle, equation of the circle in the coordinate of, say, for example, here we can see we have the two variables. So the coordinate is, the first one is the normal stress, the second one is the strain stress. Or if you want, if you wish, you can put a prime. Anyhow, basically this one indicating the Moore circles are in the spatial coordinate systems. The first coordinate by custom practice, common practice. The first coordinate are composed of the normal stress. And then the second coordinate are composed of the shearing stress. Okay, so that means here we are able to build up spatial coordinate systems. These composed of the normal stress And it doesn't have to be sigma x or can be sigma y, whatever. Okay, but this indicate is a no stress component, and this one is indicate is shear stress component. On such a special the coordinate systems, the center will be always on this horizontal axis. So here, let me put this more accurate. The center is at here. So once we are given, for example, let me work on this one. So for example here, 10, 4, and this is 4, okay? So let me utilize this as one example. So here the average we can calculate is 4 plus 10 divided by 2 equal to 7. So the center will be at the 7 here. Let me label as a C, center here. So the distance from here to here is 7. And radius, we can calculate for this calculation, that would be equal to 10 minus 4 squared plus 4 squared. So basically this equal to 5. Okay, so the radius equal to 5, so that means here this is 7 and 5 should be here. So the circle will be something like this one. Okay, so here the radius are equal to 5. So using this, based upon these two equations, and then we don't have to memorize the equation. Actually, the only thing you need to know is how to calculate the average and the radius. And then the points on the circles representing is all the possibilities, all the possible transform stress components for any value of the theta. Okay, so maybe next time we come back here, I will give more information. Up to now, we're still in review of the more circles, and then we will get to the point. I have finished the design of the homework for this chapter, and we will come to the calculation of the combined loading. Okay, so there's a one question that I'm going to